Hello, we're team number 3. This is our project for the Semana. In this project, we worked in a forecasting of sales for different points of sales from data that we were given from notice. So to start off our project, we have to identify an opportunity, and this project we focused on given a time window, we will forecast the composite demand of the pieces sold. These item pieces, it's really just different kinds of materials and the amount sold in a given amount of time. So the initial resources that we were given were a database with the information on products sold per day. And we were also given sufficient data to be able to make predictions and, well, to forecast. This is a combination of old and recent data, so we will have enough data points to make our predictions. And the sales data sets, which are managed per store, since each store has different demands. Our first approach to the problem was to use the time series as to treat this as a time series forecasting problem. We would make evaluations and decisions with these following tools that we used. We used scikit-learn, Jupyter Notebooks to organize our code, as well as Google Collaborative in order to work together as a team and contribute code at the same time. We also used Google Prophet for its ease of use, since it's a tool that allowed us to make our predictions and fit our model without much more hyperparameter tuning compared to some other tools. We also used pandas for data manipulation as well as pre-processing, since we needed to make sure that the data used in our model will be correct. And finally, we also used TensorFlow. Our initial data analysis consisted in making some graphs that will tell us how or what is the data that we're dealing with. And this helped us to realize a few key points. First of all, there is some missing information, and this missing information is missing for all points of sale. That means that there was probably an error, or maybe there was some missing reporting in this date. There's also high variability for some points of sale, while some others have more predictable and easy to read data, and this will clearly affect the results of our model. As part of our initial data analysis, we also plotted the different trends for each point of sale in order to have an initial prediction of what will be the results of our model. So we could understand if something went wrong or if it was a reasonable prediction. We can see that for some points, the trends indicate an increase in sales. And for some others, the result is completely the opposite. And we also realized that not all points are equally populated. Some datasets have much more data, and some other datasets have less data. And there are some datasets with a lot of variability as well as small variability.
Okay, so after evaluating a lot of methodologies, we chose Prophet since it's based on time series. It's good at handling missing data, trend changes, and outliers, and it works best with series that have strong seasonality and several seasons of historical data. So it really suits the problems we had mentioned before with the data. Okay, how does it work? We had to make the following process I'm going to explain with each of the stores, since, as we mentioned before, they have different sizes and it's necessary to have different hyperparameters for each of them. First, we had to clean the data. For that, we had to delete empty rows or rows that had unusable data. We had to group the sales by day and leave only those columns that we were going to be using. Then we had to split the data with the following percentages. First, 60% is for training, then the 20% following is for cross-validation, and the last 20% is for testing. And I have to mention that this data is arranged in order. So the latest data is for testing, and the oldest data is for training, for example. So then we have to do the training in cross-validation. First, we have to determine the hyperparameters and their respective values with which we would like to experiment. We use the change point prior scale and the seasonality prior scale, and we put these values. So we had a lot of combinations possible, a lot of possible combinations, and for each combination for these hyperparameters, we made the following process, which is making a prediction using the training data set and the selected hyperparameters. Then we compare that prediction against the real data, which is the one that is saved on the cross-validation set. And then we obtain the error between the prediction and the real data, which is based on the lowest root mean square error, which is the amount of error between those two data. And we obtain for all the combinations, which is the best combinations, which is going to be the least error. And we save those hyperparameters. And then we can do the last step, which is obtaining the predictions. So here we have to use the test data, which is the most recent one. As I mentioned before, the last 20% is used. And we also have to do the prediction with the hyperparameters we said before. And we obtain the predictions, which is the size of the demand of piezas. And we have to round also the predictions for each day and make a sum of all of those days to get an estimated total. So this is an example of what will happen if we didn't change the hyperparameters and just do with the profits default settings. And here we also didn't split the data. So as you can see, the prediction is like not really accurate since it uses really old data, and it's not really good compared to something where we divided the data sets. That is going to be shown next.
With this approach and the model we built, we obtained the following results, taking into account the total sales of 7 days. For the first store, the forecast is 63 pieces, and this store has a consistent sale between 0 and 10 pieces on any day, but it has a peak on Tuesday. And the trend for this store is that the sales are slowly increasing. For the second store, the forecast is 1,200 pieces, and this store sells more than 80 pieces per day, but it sells the majority of the pieces between Thursday and Sunday, and we believe this could be because the store is closed on weekdays. The forecast for the third store is 101 pieces. For this store, Monday is the biggest sales day, but in average, it has steady sales. And they also have higher sales other weeks, and this is probably because it's payday. For the fourth store, the forecast is 278. This store has great sales until the end of February. We think this is because of the season. And after that, the sales become constant, but in a smaller quantity of pieces.
For store number 5, the total predicted was 328, and this store has the higher number of sales on Mondays, and between December and February is the window with the most sales. So this is also a large store and with continuous and large number of sales. Store number 6 was a little more, the data was close to each other, and we noticed that the number of sales is almost always less than 50 pieces, but it is constant. And also, as 2 or 3 of the stores before, between January and February, there is an increase in sales. But once that period is over, the sales decrease. Store number 7 was curious because it has no sales in this period from April and May, but from June onwards, sales will always increase. So we might assume that probably they closed. It might have been a remodelation or something. And once it was over, their sales increased. Respect to the scalability of our model, we consider some changes that we would have made if we had more time, and what would we do if there was way more POS. We consider that some POS may have specific variables like the price of each item that or the total revenue, because that data could be important to know, the difference between selling a small quantity of pieces of great value and a lot of pieces of a small price. We could also add new features to the model, so it could, rerun once the data have changed. And also we could improve possible bottlenecks, because there are processes that could be done with several threads, and we just did a small part of it with multi-threading. Our next steps would be make a web application, probably in Django, because it is also in the Python environment, that will display the data, and this data would be automatically calculated every day or every week. So you could access it from a computer. You could have a user, and the data would be calculated and renewed every certain time, and a server would save the most recent and precise data, so you could always access the best prediction every day. Also, another thing we would consider is to make a multi-week forecast, because the method we use works the best when it's from just a couple of days or weeks. After that, the error gets, larger, and it could be not the best way to represent the behavior of the problem. Also, in our code, as you can see there, we use just one function that we called run stores, that would receive the number of days we want to predict, and it would make prediction for all the 7 stores we consider. One thing, I think we are proud of is, first, our model that uses this hyperparameter correction, and how it also graphs all the results for sales of any store we want. Another part here is that we could also make this profit model cross validation using multi-threading, but we did not do it in the end. We use processes parallelization, but well, we read that it was best if we had used multi-thread instead of processes, but we would need GPU or specialized hardware in order to have this run much more faster.
Something that we can also mention is that as each star have different sizes, we calculated the training set for each of them, and the test set as seen there, like that out multiplied by 0.6. So by not putting constant data like 130 days, for example, it's a better prediction because you are estimating with the data you already have. There is less probability to have errors if the size of the data is not the same.
Yeah, these are the results of our project. We are quite happy with the progress made during this week.